Now, our lesson today is about population mean estimation for small samples. And our memory verse is found in 1 Samuel 5:15, verse 19. It says, "Why haven't you obeyed the Lord? Instead, you have greedily rushed upon the plunder. You have done what is wrong in the Lord's estimation." At the end of this class, we'll be able to identify the appropriate form of the confidence interval estimator. It means the formula. Then we'll illustrate the t-distribution. We'll construct the t-distribution, identify its regions, identify its percentile, and compute for the interval estimate, and solve problems involving confidence interval estimation. We draw a conclusion. Let me share it with you one of the most distinguished personnels in the T table. There are many of them who made a research at the T table, but this one is the pioneer, I must say, or the credit is all due to him. He is W.S. Gossett, or his name is William Seeley Gossett. You might ask, who is Mr. Gossett? He was born in June 13, 1876 in Canterbury. And as a boy, he joined the Royal Military Academy in Woolwich to become a royal engineer. But later on, after he enrolled in college, in New College in Oxford, with a degree in math and chemistry, he decided to start working in a brewery. Now, during that time, people who are not in the math and physics field are not allowed to publish any. So while Mr. Gossett was working in a brewer as a brewer, he discovered, or he started to complete the T table. Actually, the T table is derived from the Z table, but it's more accurate for small samples. And since he is not allowed to publish any of his results, he used the pseudonym student. That's why this time the T distribution is also called as student's T distribution. Now, when do we use the T distribution? Here are some familiar formulas for us. Remember this formula? We have its equivalent for large samples. In this formula, the only difference is this one. Instead of Z, we use T. Instead of sigma, we use S. Now, another is a degrees of freedom. What is a degree of freedom? Or we just call it the DF. Now, the degree of freedom tells us how many values are free to vary in the sample statistic. For example, wait for a while, baby. For example, there are 5 people who decided to have 30 guavas in all. And since there are 5 of them, it would be understood that they decided that each of them will have 6 guavas each upon sharing. For example, person number 1 only got 5 guavas. The other person got 4 guavas. The other person got 3 guavas. That's 12 now. And the other person got 5 guavas. So there are only 17 guavas in all. But remember, they decided to have 30 guavas all together. So with that, what will happen? The 5th person needs to get 13 guavas in order for them to have 30 guavas in all. Now, what's the point? On 5 people, 4 people got the freedom on how many guavas they wanted to pick. But the 5th person will never have a choice. He or she should get the number of guavas needed to come up with their total number of guavas that they expected to have. You see, among 5 people, 4 have the degree of freedom. That is why in the degree of freedom, the formula is n minus 1. It means if your sample size is 10, then 9 will have the freedom to vary, but the last one will not get the freedom to vary. Now, how will we use the degree of freedom in the t-table? Again, I place a t-table in the Telegram, so hope you've downloaded it. The t-values found in the t-table can be done for one tail or also for 2 tails. These are called critical values of t. It looks very similar to the z values. We call them confidence coefficients. Now, how do we read the t-table? Here, you need to select first the probability or the area on top. On the left, in the vertical column, we have the degrees of freedom. Again, that's n minus 1. For example, if our n is 5, then our degree of freedom is 4. Next, check, is it for 2-tailed test or for 1-tailed test? For this lesson, let's have the 2-tailed test first. Then check the significance level. Example, at 10%, it means 90% confidence level. So you have 4 at 90%, so 10% significance level. The answer is 2.132. That's the tabular value. So again, let's have an example. N equals 3, 2-tailed at 90% confidence. If you check, our n is 3, so our degree of freedom is 2. So you have 2 at 2-tailed. That's 90% confidence level. So our significance level is 10%. Why? That's 100 minus 90. So you have 10. The answer is 2.920. Next, let me have letter C. N equals 4, 1-tailed at 99% confidence level. So just go to C. With n equals 4, our degree of freedom will be 3. That's 1-tailed. You have 99% confidence level. So subtract it from 100. Our significance level is 1%. Find its intersection. Our tabular value is 4.541. Ma'am, what if the answer or the degree of freedom is not in the table? Let me show you the table. Example. Your n is 110. So with that, the degree of freedom will be 109. But if you check the column for the degree of freedom, 109 is not found here. So what will you do? You go to the number before 109. So we use 100, not 120. You use 100. So that's how you do it if it's not found in your t-table. Now for your activity number 1, it's finding the t-value. As easy as that one. Now let me continue.